In this video, we're going to begin to explore special segments and triangle centers. Just a quick note, there are many very similar, or at least sounding similar, concepts in this unit. So before we start, we're going to have a vocabulary list that helps you understand the precise language of these triangle centers. So make sure that you don't get confused. You don't confuse them with each other. So let's start with the first one. A mid-segment is a segment that joins the midpoints of two sides of a triangle. So it's the midpoints of two sides. So in other words, find the midpoint of one side AB and find the midpoint of the other side BC. And now if you just join the two sides, so you just do this. So your D is the midpoint of AB, and your E is the midpoint of BC. So you create two pairs of congruent segments. Next, perpendicular bisector. A line, a segment, or array that divides a segment into two equal parts. So it's two equal parts, and it's perpendicular to the segment. So if I have AC, for example, and if I find, first find the midpoint, and then I draw a line or a segment like that, that's perpendicular. So notice that if I call this D, AD is congruent to CD because D is the midpoint, and this line that passes through the midpoint D is perpendicular to AC. Angle bisector, I'm not going to go into details. By now you all know that it's just a line that divides an angle into two equal parts. So you can have a line or array that divides angle A, and then that gives you two equal parts. A median is a segment that connects vertex of a triangle to the midpoint. So it's a vertex to midpoint of the opposite side. So let's take a look here. If I have a vertex B there and I look across that triangle, opposite side is AC. Now if I find the midpoint D, and now if I connect, midpoint is D on AC. Now I connect the two dots. I have BD, that segment. That's called the median. Okay, so very often this is a more challenging concept for some students because I guess it's just easier to be overlooked or something. Students sometimes make mistakes on this. So again, this is called the median right here. Next, altitude. This one people sometimes struggle. I don't actually quite understand. So conceptually, an altitude is simply a segment that connects a vertex of a triangle to the opposite side so that it's perpendicular. So unlike the median, it doesn't connect the midpoint. So it's this is vertex, so that it's perpendicular to the side. So if I just go from the vertex B and drop straight down, notice I don't draw the tick marks. AD is not necessarily congruent to DC. It could be, but it's not necessarily congruent to DC. But BD has to be perpendicular to AC. That's called an altitude. And very often, we also call this height. So if you look at a mountain, you say how high the mountain is. You go from the top of the mountain and go straight down and draw a perpendicular line to the ground, right? You don't walk down the mountain and then measure the hypotenuse. So that's called the altitude or the height. Circumcenter is the point at which the three perpendicular bisectors intersect in the triangles. So perpendicular bisector. Remember perpendicular bisector. I'm sorry. Remember what am I talking about? Perpendicular bisector is the segment that divides the sides into two equal parts, and it has to be perpendicular. So there are two conditions, right? There's one condition that's perpendicular, and another condition is bisect, meaning cutting it in two equal halves. So let's look at this. In this example here, I have MZ that cuts AC in half, and it's perpendicular. Then I have MY that cuts BC in half, and it's also perpendicular. And then finally I have, let's see, different color. I'll use gold. I have MX, that's gold, that's perpendicular and cuts the sides in half. And guess what? These three meet in the exact same spot, and that spot, let me get a different color. I'll use purple. That spot here called M, that's called the circumcenter. All right. Now, incenter, circumcenter is not to be confused with incenter. Incenter is the point at which three angle bisectors intersect. So this is where the angle bisector intersect in the triangle. So again, let's look at AM. It cuts this angle by half. Now let's look at, give me a red. Let's look at BM. That's cutting angle B by half. And give me a gold one. And CM, that's cutting angle C into half, right? So these three are angle bisectors, and they too meet at one point, and that point is called the incenter. Okay? Let's see. Centroid. Centroid is the point which the three medians intersect. And recall, median is the segment that connects the vertex to the midpoint of the opposite side. So really we're talking about, just give me this one right here, right? We're really just talking about where all the medians meet. Okay? Finally, there's orthocenter. Orthocenter is the point at which the three altitudes meet. So that's pretty self-explanatory, and I'm not going to go through it again, but notice that these are just all the altitudes meet at one point as well. So I think very often the last four concepts, circumcenter, incenter, centroid, and orthocenter, are the most challenging because they're built on top of the four basic concepts. So that's when people get confused. So just remember, circumcenter relates to perpendicular bisectors. Incenter relates to the angle bisector. Centroid is in relations to medians, and orthocenter is in relation to altitudes. All right, so it's quite a bit of concept, but I thought I would throw it out there, give you a quick preview or a review. And we'll move on to the next unit soon. Bye, guys.